Alright guys, so now let's have a look at how galvanic cells work using redox reactions. Alright, so basically a redox reaction, as we know, involves the movement of electrons. And what this means is that chemical energy is converted into electrical energy through oxidation. In other words, as the reductant is oxidized and loses its electrons, it causes the electrons to move, which is electrical energy. And the current is the amount of moving charge, which in this case is electrons. So what is a galvanic cell? A galvanic cell is able to produce electric current from a redox reaction that occurs within it. And as you can see, we've got zinc sulfate, copper sulfate. We've got all the makings of a good redox reaction happening here. So in most in most redox reactions, the electrons are transferred directly from the oxidant to the reductant. From the oxidant. That's not right. As the zinc is oxidized, that makes so zinc is oxidized. That makes it the reductant. So the electrons are transferred from the reductant to the oxidant. And the galvanic cell essentially involves the oxidation over here and the reduction over here in different parts, so different half cells, different parts of the cell. Now, basically, the oxidation and reduction half cells are made up by a circuit, that's here, or an external circuit, and a salt bridge connecting them. Okay, so we've got half cell here, it's connected by a salt bridge, and an external circuit. And electrons pass through the external circuit, which will be a wire. And that's what gives us the current. That's how galvanic cells work. Now, the galvanic cell allows the conversion of chemical energy into electrical energy. Alright, so here's our one I'm going to have a look at as an example. Remember, oil rig, oxidation is loss, reduction is gain. Here we have oxidation occurring, and here we have reduction occurring. You see that the copper is being reduced. Now, what we have is first things first. What the zinc is oxidized, so it loses 2 electrons. Okay, so it loses 2 electrons, and these pass through the wire and into the copper. Okay, and this is elemental copper. Now, as this is here in the elemental copper, we'll see that it attracts, because they're negative, it attracts this positive copper ion, this cation. So the cation is attracted to it, and watch this and watch this guy here, they're about to disappear. We'll see that the copper ion here becomes elemental copper, and his deposition is happening. This will grow in size. And this was the elemental zinc, which has now left and gone into solution. Now you'll see there's also been a change in our salt bridge. So we'll go back. The salt bridge has, in this case, sodium chloride. So it's essentially, it can be anything really, as long as it's moist and has a dissolved salt in it. So here we have positive sodium ions, negative chlorine ions, or chloride ions, and we have sodium chloride. Now, what happens is, this is about to move into solution here, and as it does, so there's now more, these blue ones, these are sulfates, so blue ones are sulfates, and we have more positive charge than we do negative charge. So there's one extra zinc ion, cation, than there are sulfate anions. Now, what this means is it needs to even out. So two of the chloride anions leave the salt bridge and go in the solution over here. So this is now zinc sulfate plus chloride ions. Over here, we've actually lost a copper ion. One of the copper cations has become elemental. Okay, so the copper has gone to Cu, solid, which means it's been replaced by sodium ions. So this is now plus. And you'll know that 2 went in, but to make up for the 1 copper ion that's missing. So in our salt bridge, we have movement of ions, and in our external circuit, we have movement of electrons. And you should make a note of that. One last thing, it's important to realize that this is called the anode, and the anode is the electrode where oxidation happens, which means it is also the anode that attracts anions. The cathode is the electrode where reduction happens, and it is the electrode which attracts electrons. Now, a good way to remember this is anox, so anode, oxidation, anox, red cat, reduction, cathode. Alright, top work. See you later.